The Michelin Attack Plus method of checking vehicle alignment is simple, yet effective, using tools and equipment found in most toolboxes. You will need a chalk line without the chalk added, metal millimeter tape measure, flashlight, toe scribe, 2 cans of white spray paint, 2 large contractor-quality plastic trash bags, piece of chalk, 4-foot straight edge or level, heavy-duty jack, 2 heavy-duty jack stands, wheel chocks, T45A tire iron, and a copy of the Vehicle Measurement Worksheet or VMW to record your measurements. The best way to ensure accurate results is with proper setup. Position the truck on a smooth, level surface, avoiding areas where one or more axle ends are located in a floor drain or similar depression or protrusion. Drive the vehicle in a straight line at least 2 to 3 vehicle lengths into the inspection area to ensure that the axles are in their normal straight-ahead positions. Stop carefully. Let the truck slow to a stop by leaving it in gear and turning off the engine. Then release the clutch to stop. Do not hit the brakes, because this could affect axle position. Securely chock the vehicle to prevent unwanted movement. Using the Vehicle Systems Inspection Worksheet or VSI, record vehicle information such as vehicle number, VIN, mileage, and inflation information such as air pressure, tread depth, and wear patterns. Visually check the vehicle for anything that may indicate problems with the steering or suspension system, such as kingpins, tie rod ends, leaking shock absorbers. Use manufacturer's specifications to check ride height. Confirm that steering stops are in place on both sides. Verify the air system is charged to 100 psi so that airbag height is correct. You are now ready to start checking the truck's alignment. In order to determine if the steer axle is skewed, measure the distance from the Zerk fitting to the U-bolt on the front axle interface. If there is no Zerk fitting, measure from the center of the spring pin to the U-bolt. Repeat this measurement on the other side of the vehicle and record the results in millimeters in the AL and AR boxes on the VMW worksheet. Ensure that the front tires are steered straight ahead by measuring the distance between the inside rim flange and the leaf spring on both left and right sides of the vehicle, and record the results in the BL and BR boxes on the worksheet. These distances will be the same on both sides when the tires are steered straight ahead. Mark a reference line on the steering wheel and steering column with chalk for future reference. Now measure from the frame rail to the rim flange on both sides of the vehicle to get the steer axle offset. Be sure to double-check the frame configuration. Rails may not be parallel on both sides. Record each measurement appropriately on the VMW worksheet in boxes CL and CR. Confirm that the rear wheels are chocked for safety, and then raise the front axle with the jack so the tires are approximately 1 inch off the ground. Position jack stands under each side of the steer axle for safety. When elevated, use a T45A iron to check both sides for excessive wheel bearing and kingpin play. If the kingpin has excessive play, the brake chamber will show movement. If the wheel bearing has excessive play, the movement should stop when another technician applies the brakes during this check. Mark each tire with a scribe line by selecting a rib with minimal siping. When the tire is spinning, spray a light coat of paint around the tire. Next, carefully scribe a thin line in the paint around the entire circumference of the tire, avoiding the siping in the tread design if possible. After this is done for both tires, check to make sure they are still steered straight ahead by measuring from the rim flange to the leaf spring on both sides, or check the alignment of the chalk reference marks on the steering wheel and column. Take a large plastic trash bag, heavy-duty type is best, and fold until it is slightly larger than the tire footprint. Place one bag under each tire. Remove the jack stands and lower the jack. Failure to use a folded plastic bag or other frictionless surface, such as slip plates or turn plates, will result in the tire wheel assemblies contacting the ground in an abnormal orientation and produce incorrect tow readings. Confirm the vehicle is still positioned straight ahead before proceeding by checking the chalk mark on the steering wheel and column and validating measurement. Place a paint can in front of each tire at the scribed lines. This measurement must be done at the same height on both sides, and the paint cans will make a good reference point. Measure the distance between the two scribed lines on the rear side of the tires. The best practice is to start at the 100 mm mark on your tape measure to eliminate compliance in the tape end. Record this number in the green toe measurement box at the top of the VMW sheet. Repeat this measurement at the back of the tires, again at the height of the paint cans, and record. The difference between these two measurements represents the static toe-in or toe-out of the steer axle. If the distance is less in the front than the rear, the tires are towed in, and if it is greater in the front, they are towed out. For example, if the reading is 2032 millimeters in the front and 2036 millimeters in the rear, then the truck has 4 millimeters of toe in. Readings outside a range of 1 to 2 millimeters indicate that corrections are necessary. Ideal toe in is 1.5 millimeters or 1/16 of an inch. To measure the offset on the drive axles, rest a 4-foot level at a 45-degree angle against the outside of the rear tire. Measure from the outside of the frame rail to the edge of the level for greatest accuracy, and record the values in boxes DL and DR. If you are checking a tandem axle vehicle, repeat this process for the rear axle and record results in boxes GL and GR. Measure up to the center of the hub and mark the tire. Place the tape measure at this mark, pushing the end toward the rim flange to remove any compliance in the end of the tape measure. Measure from the edge of the rim flange on one side to the front rim flange on the other drive axle. It doesn't matter where you start. Right-handed people usually put the tape end on the left tandem and the measuring end on the right. To ensure a repeatable measurement, slowly swing the tape up and down, looking for the shortest distance. Perform this measurement on the opposite side of the truck or tandems. Record these values in FL and FR on the VMW. This can also be done by using a trammel bar to check center-to-center distance between the tandem axle ends. Any difference between the two sides greater than 3 millimeters or 1/8 of an inch should have an alignment performed, or excessive steer tire wear will result. The next step is to check the thrust line. This determines if the front tandem is skewed relative to the steering axle. Using the string line, hook the end of the string onto the tire or other convenient location on the rear side of the front drive axle. Run the string forward to the front wheel at hub height if possible. On vehicles with full aerodynamic skirting packages, the bottom of the hub face is usually the best option. Position the string so that it just touches the forward and rear sidewalls. Be careful to avoid bold lettering and designs on tire sidewalls, which will affect results. The string now represents a line perpendicular to the axle itself. Measure the distance from the string to the wheel either at or just below the dust cap at the front wheel bearing, or at the bottom of the wheel hub for trucks with aerodynamic skirts. Record the values from both sides of the vehicle in boxes EL and ER on the VMW. Compare the readings to determine which side is higher and by how much. The side with the highest number indicates that the drive axle is angled to that same direction. For example, if the reading on the left side is 25 millimeters and the reading on the right side is 61 millimeters, then the thrust line would be angled to the right. Differences greater than 25 millimeters on vehicles with wheelbases longer than 200 inches indicate excessive axle thrust. Any vehicle, once aligned, will stay aligned except for 3 reasons: worn, bent, or broken parts. Identifying these components is an integral part of the alignment process because a properly aligned truck with these components will return to misalignment as soon as it leaves the shop. Common areas that need to be checked include tie rod ends with tolerances of 60 thousandths of axial play, drag link, also with tolerances of 60 thousandths. Kingpin. If the vehicle is properly lubricated, kingpin life is very long. Wheel bearings. Tolerances are 1 thousandths to 5 thousandths on adjustable wheel bearings. For vehicles with outboard-mounted brake drums, the cleanliness of the mounting surface or hub boss is critical. Check for signs of excessive wear in the spring pin perch. Spring shackle pins and bushings should have no play. Also check for signs of excessive wear in spring eye bushings. And don't overlook hidden parts. Inspect the suspension to frame fasteners, whether they are normal bolts or huck bolts, and check for signs of loosening, such as disturbed paint or rust streaks. Examine the suspension pedestal, looking for cracks or signs of loosening. Look for excessive wear in the rear suspension bushings and in the bushings of the torque arms or panhard rods. And finally, ensure that U-bolt torque is correct to manufacturer's specifications. Remember, a major step in achieving optimum tire performance is monitoring correct axle alignment, which includes a thorough examination of suspension components. Use these simple techniques to effectively monitor the alignment of your vehicles and get the most out of your tires. Don't forget to check out the bib alignment system video for information on accurately validating vehicle alignments and calculating any corrections that might be needed.
Michelin, a better way forward.